The invention of the transistor in 1947 has an impact on modern life in the fields of communications, personal computing, military development, space exploration, and transportation. Most notably, transistors are found on integrated chips in personal computers. According to software research company Gartner, the number of installed PCs worldwide has surpassed 1 billion units, and that number is rapidly growing. All electronics, including phones and computers, contain millions of tiny transistors printed on chips, working as an army to accomplish calculations. To find the origins of the transistor, we need to travel back in time to the humble beginnings of the computer, the vacuum tube. A vacuum tube is a device controlling electrical current through a vacuum in a sealed container. Thermionic vacuum tube triodes, useful for amplifying, rectifying, and oscillating, were created in 1906 by Lee de Forest. De Forest's invention, called the Audion, was based off the earlier invention of the vacuum diode, useful only for rectification, by Ambrose Fleming. In this way, the Audion could amplify signals, making it useful for radios. In addition, the device could rectify and oscillate signals. Because of those many functions, vacuum tubes had uses in the early 20th century.
Here's one of them, changing AC to DC on the nation's electrified transportation system.
One such device is the well-known Electronic Numerical Integrator and Computer, or ENIAC. This computer contained over 19,000 vacuum tubes and drew enough power to occasionally produce brownouts in Philadelphia.
There's typically 5 reasons or 5 big advantages of the semiconductor transistor versus the vacuum tube. And you can almost tell intuitively what they are. Obviously, the first one is size. Here we have 2 huge vacuum tubes versus a wafer with literally hundreds of integrated circuits. These are highly powerful microprocessor chips that go into cars and planes and boats and trains. So size is certainly an issue. These get really hot, like light bulbs. These hardly get hot at all by themselves. So power consumption is another big issue. These are extremely fast and high performance and very powerful, so they can process billions and billions of calculations per second, whereas these were much, much slower, and we're not able to do that. Reliability is much higher on these than on these.
As a replacement for the inefficient thermoionic triodes of the day, an Austro-Hungarian engineer named Julius Edgar Lilienfeld designed an entirely new device in 1926. While his patent lists the device as a method and apparatus for controlling electric currents, we now know Lilienfeld's design as the field effect transistor. A transistor is a semiconductor device with 3 connections, similar to the vacuum tube. The device includes an emitter, which is negatively charged, a collector, which is positively charged, and a base, which is varied in voltage or current to affect the current flow through the device. Since transistors are made from semiconductor material, their conductivity can be affected by varying the concentration of charge carriers within them. A charge carrier is either an electron, which has a negative charge, or a hole, which is a lack of electron, which represents a positive charge. Unfortunately, Lilienfeld didn't understand the principles behind his device, and mass-producing it was not possible with early 20th century technology. Because of this, the FET had no immediate impact and was forgotten in light of the next significant invention.
1947 was the year that the point-contact transistor was invented. The point-contact transistor was created largely by 3 men working through Bell's labs.
Bratton was a very talkative, friendly, outgoing person. And an experimentalist. Bardeen was a very thoughtful and shy person. And Bardeen and Bratton formed a very close relationship as a team. Shockley was an all-around brilliant person, a bit of a promoter, and he is important in the story because he got the whole thing going. Because he didn't have the perseverance to work through problems when they started, he went off and did other things.
A New York Times article, published the day after the team's discovery, said,
"The transistor contains no vacuum, grid, plate, or glass envelope to keep the air away. Its action is instantaneous, there being no warm-up delay since no heat is developed as in the vacuum tube.
There had been similar attempts at creating something like this transistor before, but none had led to similar widespread recognition or impact. The transistor was not instantly significant due to the fairly high cost, but by January 1954 it began to show how useful it was. The U.S. Army needed faster, more efficient calculations at the time, when vacuum tubes were already outdated in the phone system. Despite the transistor's major disadvantage in the 1950s, that it cost 20 times more than a vacuum triode, the military encouraged Bell Labs to produce the first fully transistorized digital computer, TRADIC. This new computer contained almost 800 point-contact transistors and 10,000 germanium crystal rectifiers. Although it wasn't as fast as the computers of the time, it consumed less than 100 watts of power, equivalent to a large light bulb, and it was considerably smaller.
The invention of the transistor soon had a noticeable impact on the entertainment industry. Vacuum tube radios, standard in the 1940s, were bulky, heavy, and fragile enough so that they couldn't be used portably.
It's the Skylark, Sylvania's new personal portable radio. It weighs less than 4 pounds with batteries.
With the invention of handheld radios, like the Lincoln 6, people could listen to music and talk shows wherever they went. This, along with the appearance of musicians like Elvis, led to radios becoming the icon for teenage independence. They sold like wildfire. In 1948, William Shockley invented the grown junction transistor, also known as the bipolar junction transistor, or BJT. The first bipolar junction transistors were enclosed in a hard plastic bead, about 3/16 of an inch in diameter.
William Shockley is known as the father of Silicon Valley, since he moved out to Mountain View, California, and began operating Shockley Semiconductor Laboratories under Shockley Transistor Company. Because of his tyrannical attitude, 8 of his top co-workers left in 1957 and formed Fairchild Semiconductors. These men, known as the Traitors 8, were Julius Blank, Victor Greenwich, Gene Horney, Gene Kleiner, Jay Last, Gordon Moore, Robert Noyce, and Sheldon Roberts. This new company and some of its members went on to produce significant breakthroughs in electronics. On March 17, 1958, the spacecraft Vanguard 1 successfully launched in Cape Canaveral. Relying on multiple computers consisting of miniature transistors, the satellite is still orbiting Earth and holds the record for longest orbiting man-made spacecraft. The entire time, it has transmitted data about the Earth's shape back to us. In 1959, Jack Kilby from Texas Instruments, looking for a way to make an electronic calculator, and Robert Noyce from Fairchild developed the integrated circuit, commonly known as the IC. This technology allowed multiple electronic parts to be printed onto a chip, the first one being made of germanium. Instantly, chips were capable of becoming smaller and smaller, leading to another revolutionary breakthrough. Gordon Moore and Robert Noyce split away from Fairchild to form Intel. In 1971, as part of an assignment for Nippon Calculating Machine Corporation, the company created a new type of technology known as the microprocessor. The first, Intel 4004, contained 2,300 transistors and was approximately the size of a small fingernail. Microprocessors contain the functionality of multiple computer parts in one small package that's capable of being programmed.
Modern commercial automobiles delegate almost all functions to onboard engine control units composed of typical microprocessors, contributing to a greater fuel economy or greater power levels. These systems have been in place on most automobiles since the early 1980s, when they were tested as ways to reduce emissions. Even the medical field is affected by transistors and microprocessors. Medical monitors developed to keep track of patients in hospitals use microprocessors to operate.
But certainly I would say that it is one of the very largest turning points.
The transistors and later microprocessors that were made possible by semiconductor research in 1947 now make our phones smaller, computers faster, cars more safe and efficient, spacecraft more useful, military more advanced, aircraft safer, and the medical advances enabled by the invention of the transistor help to ensure that we will be able to more fully enjoy these advances with longer lives. The invention of the transistor has provided an enabling technology for all of electronics in the 20th century and beyond, which has resulted in a turning point in history. As transistors continue to improve, one can only imagine the impact that they will have on our lives in the future.